Hi folks, time for a new chapter. We'll call this chapter 6 and part 1. We're going to talk about the price elasticity of demand as an exemplar for elasticities generally speaking. But the price elasticity of demand is oftentimes one of the most important elasticities that you'll deal with, and it'll help us to learn about the concept. The concept of elasticity isn't difficult at all, I don't think, but learning to work through some of the equations and how to plug in and calculate can sometimes get a little fuzzy. So I'll try to clean that up as we go along. Okay, the first thing that you want to make sure that you're straight on is that elasticity is a general tool. It can be used for anything. So if we start talking about the elasticity of something A with respect to something B, in an equation form, this would be the percentage change in A divided by the percentage change in B. Okay, and that would be discussed as the elasticity of A with respect to B. Now that might be how many kisses do you get at the end of a date when you change the percentage of roses that you bring at the beginning of a date. What percentage increase in medals might you win when you increase the amount of practice? How are earnings related to education? You can relate any of these two variables together, okay? Or any two variables, period. We'll focus first on this quantity demanded and price relationship, and the generalized way that we would write this is the percentage change in quantity demanded with respect to the percentage change in price. And this is an obvious and sensible thing to be concerned with, because any producer is going to start to wonder, as prices change, how will quantity demanded change with it? You know that as price goes up, you're going to lose some quantity demanded, but you'd like to know how much. Is it going to be a big response? Is it going to be a small response? How is that going to affect total revenue, right? Okay. When you actually calculate out the numbers for those elasticities, they're going to fall into three ranges. If that number comes out to be greater than 1 after you take the absolute value of it, then you are going to have an elastic response. And note this absolute value. If you think about it, price and quantity demanded are inversely related. So it would imply that that fraction from our last slide was always negative. Economists generally don't like to deal with that. Oftentimes they'll take the absolute value so that they always have it in positive numbers. It's just easier to talk about elasticity getting bigger as the number gets larger. So for the purposes of our lecture, I'll always assume that we're going to use the absolute value bars on that general equation that we put out last time. Okay, so if you calculate that and you get a number that's greater than 1, then this means that the percentage change that you got out of the quantity demanded, right, was larger than the percentage change in the price. So something like there was a 10% increase in quantity demanded when there was a 5% decrease in price. Take the absolute value of this, and we end up with a value of 2. So your elasticity would be equal to 2. It's greater than 1, and we would describe this as elastic, or some people like to think about it as responsive. Sensitive is another synonym. What it means really is that for every 1% increase in price, you can expect that there will be a 2% decrease in quantity demanded. Keep in mind, we took the absolute value bars. Otherwise, this would have been a negative 2. Okay, now sometimes you'll calculate these numbers out and you'll find that you get something like there was a 5% decrease in quantity demanded when there was a 15% increase in price. And of course, with the absolute value bars, you're going to find that this is going to be equal to 0.33, right? With a bar over it, I suppose. A third, essentially. less than 1. And if it's less than 1, then you're going to refer to this as inelastic, or you could think about it as not being particularly sensitive to changes in price. Lastly, you could calculate it out, and you could find that there was a situation where perhaps there was an 8% increase in quantity demanded when there was an 8% decrease in price, and you'd have a value of 1. If you have a value of 1, it means that you are gaining the same percentage in quantity demanded that you are losing in price, or vice versa. Okay. Unit elastic is another way that we describe this. These are the three ranges. We'll come back to them in a second because you're going to see that they're really relevant for what's happening with total revenue. Okay, so we know that when we do our calculations with quantity numbers and price numbers, if we see that the number is greater than 1, it's elastic, or we're going to describe it as sensitive. If it's less than 1, it's inelastic. Another way that you can think about this, though, is what makes it likely that you're going to see an elastic or an inelastic response for any particular good. Well, here's a list of determinants, and we can start talking about these and their relationship to elasticity. So this first one here, more substitutes. The more substitutes that you have, the larger that you are going to expect the elasticity to be, all else held constant, right? More substitutes means that if the price goes up, it's pretty easy for the consumer to find another option. So you're going to expect to see that quantity demanded drops pretty precipitously. The larger and larger the share of the budget, you will also expect that you have a higher price elasticity of demand. Okay. If it occupies a large portion of their budget, they're going to be pretty sensitive about it. On the other hand, if it's something like a pack of gum and it's really cheap, they might not even notice if you raise the price. You're going to end up with a very low price elasticity of demand. Okay. The more narrowly a market is defined, the more that you are going to expect that you end up with a higher price elasticity of demand. You can think about this market definition and its relationship to substitutes. If you're talking about something like a plasma screen television. A plasma screen television is going to have a higher elasticity, price elasticity of demand than you would expect televisions in general to have. The reason being is that if the price of a plasma screen TV goes up, you can pretty easily go and pick some other kind of television. However, if the price of TVs rises in general, you might have a more difficult time replacing them. There aren't as many substitutes. So the more narrowly defined the market, the higher you're going to expect the price elasticity of demand to be. Okay, the last one that we'll talk about is the long run. And what I mean by the long run is just essentially elasticity changes over time. When you force a higher price on someone in the short run, immediately, it's difficult sometimes for them to change behavior, to cut back on quantity demanded as much as they might if you gave them more time. If you give them more time, they can find other acceptable substitutes, they can rearrange their consumption bundles, they can do all kinds of things to help them avoid those higher prices for your good. A good example of this is gasoline. Gasoline in the short run is very, very likely to be inelastic. Okay. However, in the long run, we would expect it to show a more elastic response, at least relatively more elastic than it was before. If the price of gasoline goes up by $2 a gallon today, you're going to have a hard time buying any less gas than you probably would have bought anyhow. But if it stays like that, over time you're going to start figuring out carpools. You might ride your bus to work. You might start figuring out van shares. Any way to start, arranging trips and errands so that you use less gas. You'll figure out ways to buy less gas if gas is going to be that much more expensive. Okay, so given enough time, in the long run, we would expect that elasticity is going to be higher than it would be in the short run.